Hey guys, it's Off1 here, and today we're going to be solving longest common subsequence. In this problem, we're given two strings, text1 and text2, and they want us to return the length of their longest common subsequence. And if there's no common subsequence, then we return 0. So what is a subsequence? So here we have an example, ACE, and they're saying this is a subsequence of A, B, C, D, E, and we can see that the output should be 3 because this is ACE, and this contains A, C, and E. So that's what our common subsequence would be. So normally to start these problems, I either solve it manually or use the brute force method to get us to the answer. But for this problem, I feel like the brute force approach is more complex because it involves recursion. So we're just going to start with the dynamic programming solution. So to start, I'm going to set up a two-dimensional array so that way we can keep track of our matches. So it would look something like this. So here we have our 2D array that is length n going this way and length m going this way. So our space complexity is going to be O of n times m. So how do we fill this in? Let's just start by filling in the coordinates where the letters match. So for example here, A and A match, so we're just going to fill it in with a dot for now. And then we see that C and C match, so we're going to fill this up with a dot too. And we see that E and E match, so this is going to be filled with a dot. But the problem wants us to return an integer, so for example, since the longest substring that matches is 3 here, then we want to return a 3. So let's just change these values to be 1, and then 2 because this is going to be our second match, and then 3 here because that's going to be our third match. And then at the end, we want to return this coordinate here because that should return the length of the longest common substring. So now that we know that, how do we actually get these values here? So for example, how do we know to put a 2 here and a 3 here? Well, we could add 1 to this value here, but it would be very hard to access that since we don't know when this value would actually happen. Well, one other thing we can see is that these matches have to happen in a diagonal form because you can't have a 2 here since A cannot be part of that substring since it's already part of this one. But this can be a 1, so now when we find a match, for example here, all we have to do is add 1 to this diagonal and store it here. So for example, we would look at this diagonal here and see that a 1 is there, and then add a 1 to it, and then now we can store a 2 here. And similar thing here. There's no match, but we can just take this value and put it over here as well. And then when we find another match, we add a 1 to this and store it here, so we would get a 3. So for our pseudocode, we can just name this array result, just to make it easier to reference. And now we want to do, if these letters match, the current letters we're looking at, then we want to add the diagonal plus 1. So it would look something like this. So here we see our condition. So if the current letters we're looking at match, then we want to set our current index equal to the diagonal, so for example here, plus 1. But as you can see, here we were getting out of bounds error since this 0 doesn't actually exist in our array. So the way to fix that would be to add another column and row on top of all of this. And then all of these will be set to zeros, so we can access them at some point. So this example is getting pretty messy, so I'm going to clean it up and then we can go from there. So I've cleaned it up now, and now I've initialized all this extra space to 0 because we're only using it to access the diagonal. And now we want to figure out what we want to do for our else statement in case the letters don't match. Well, let's see. If our letters match, we want to add 1 to our current diagonal. So these letters match, meaning that this will be equal to 0 plus 1. So this is 1. And now we go to the next iteration. So B and A, those don't match. But what do we want to put here? Well, we want to carry this 1 over here. So I guess we can just take the max between this and this. So this would be 1. And then now when we get to our C and C combination, all we have to do is add 1 to this value because that will be the diagonal at this point. So this will be 2. And then similar thing here. No matter what this value is, we want to carry this 2 forward because we found our match here. So this would be a 2. So basically what we see here is that we want the max between the left and the number above the current iteration we're at. So the way to write this would be, we want to update our result at current to be equal to the max between our result at the left and our result above. And that should be it as far as our pseudocode goes. Our time complexity for this algorithm would be O of n times m. The reason being that every time we iterate through a letter here, we have to iterate through all of these. And if you remember, this is length m, and this whole string here is length n. So because we're doing nested for loops, we're going to need n times m time. And for space, it's the same thing, because the array is going to be of size n times m. And there is a solution that only takes up O of n space, but this solution is a little less intuitive, and with this channel I just want to stick with intuitive solutions that are acceptable for an interview. So now let's get into the code. To start, I just want to initialize two variables, one to keep track of the length of text 1, and one to keep track of the length of text 2. The reason I'm doing this is just to save a little bit of time in the code. It's not really necessary to do this. And from here, I just want to do our 2D array, and I want to initialize every single value in there to be 0. So for our columns, it's going to be 0 for j in range of length 2 plus 1. And the reason I'm doing length 2 plus 1 is because range is not inclusive, and we're going to do the same thing out here for our rows. So for I in range of length 1 plus 1. So now we have our array, and we can just start iterating through the text. So for I in range of 1 to length of text 1, and the reason we're starting at 1 is because if you remember in our drawing, we had an extra row and column that we're not going to use, only for accessing the diagonals if necessary. So we're going to do the same thing for this for loop, where we're starting from 1 all the way to length of string 2. And then I would just want to check if our texts are equal. So to do that, we would check I minus 1 and j minus 1. The reason for that is because if you remember, we're starting from 1 here, and this is just to not have an off by 1 error. And now we just want to update our result array at our current iteration to 1 plus the diagonal, which would be result at I minus 1 and j minus 1. And now we do our else statement. So otherwise we want to update our current result to be equal to the max between our upper bound and our left index. So it's going to be result at I j minus 1 and result at I minus 1 j. And that should give us the left index and the upper index. And then after this, that's pretty much it. All we have to do now is return our result array at index length 1 and index length 2. Also here I forgot to put length 1 plus 1 because it's not inclusive. And then now this code should work. So as you can see, this code is fairly efficient. And now I'll go through the code manually. So for this example, I'm going to use these texts, and I've already initialized our array here. So our array result is going to look like this. And now we just iterate through the text. So we're going to start here at this A, and J is going to point to this A first. And now we check. Are these letters equal? Yes. So what we want to do is add 1 to this diagonal here and store it here, which would be 1. And now we go to our next letter, E. Well, we can see that A and E don't match, so here what we're going to do is have our left or the index above us, and we're going to take the max between those two and then store it there. So let's see. To the left is a 0 and above is a 1. So the max between 0 and 1 is 1, so we're going to store that there. And now we move on to this index. So for this index now, we want to start at A again, and we want to check if they're equal, and we see that they're not. So what we're going to do is go to this condition here, and then now we see the index at the left and the index above us. Which one has a greater value? Well, we see there's a 1 at the left and a 0 above it. So what we're going to do here is put a 1. And now we go to the next iteration, which would be E. And now we see that these two characters match. So what we're going to do is update our current result to be equal to 1 plus the diagonal. And the diagonal is 1. And so we're going to have 1 plus 1, which would be 2. And then at the end, we return the bottom right index of this array, which would be 2. And that is the longest common subsequence between these two strings. So we know that's right. If this video helped you in any way, please leave a like and subscribe. Thanks for watching, and I'll see you in the next video.